Hi students, good morning to all. Grade 12 Mathematics. Today is same unit, continuous of chapter number 2, inverse trigonometric function. Inverse trigonometric function. Take your NCERT book, page number 42. Exercise 2.1. Question number 1 to 10 already completed last class. Today, question number 11. Question number 11. Find the values of the following. Find the values of the following. Tan inverse of 1. Tan inverse of 1 plus cos inverse of 1 by 2 plus cos inverse of 1 by 2, minus 1 by 2 plus sine inverse of minus 1 by 2. Find the value of tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. Okay, right. Listen. First of find tan inverse 1 value, and second cos inverse minus 1 by 2 value, and third one so find sine inverse of minus 1 by 2 value. So sum of the three values is equal to the required answer. Okay, right. Listen. Tan inverse of 1. Tan inverse of 1. Let's x equal to tan inverse of 1. X equal to tan inverse of 1. Tan x is equal to 1. Tan x is equal to 1. You know that tan pi by 4 is equal to 1. Tan pi by 4 is equal to 1. So tan x equal to 1 is also equal to, so 1 is written as tan pi by 4. Tan pi by 4. We know that the principal value of tan inverse x is open interval minus pi by 2 comma plus pi by 2 open interval. This is a principal value in tan inverse x. Okay, right. So tan x equal to 1 is also equal to tan pi by 4. So tan x is equal to tan pi by 4. Then x equal to pi by 4. X equal to pi by 4. So this value pi by 4 is blanks to principal value of tan inverse x, open interval minus pi by 2 comma plus pi by 2 is blanks to open interval minus pi by 2 comma plus pi by 2. So therefore tan inverse of 1 is equal, x is tan inverse 1, so tan inverse of 1 is equal to pi by 4. Tan inverse of 1 equal to pi by 4. Okay, right. Next, second one, cos inverse of minus 1 by 2. Let's y equal to cos inverse of minus 1 by 2. Y equal to cos inverse of minus 1 by 2. Right. You know that cos inverse x, principal value of cos inverse x. Principal value of cos inverse x. Principal value. You mean principal value of cos inverse x is close interval 0 comma pi. Close interval 0 comma pi. Right. Let us consider y equal to cos inverse of minus 1 by 2. Then cos y is equal to minus 1 by 2. Cos y equal to minus 1 by 2. You know that cos pi by 3 value is 1 by 2. Cos pi by 3 value is 1 by 2. Here minus 1 by 2. So minus 1 by 2 is equal to minus cos pi by 3. Okay, so cos pi by 3 value is 1 by 2. Here minus 1 by 2 is written as minus cos pi by 3. Minus cos pi by 3. So cos y is equal to minus cos pi by 3. Minus cos pi by 3. And cos of minus pi by 3 is plus cos pi by 3. So minus cos pi by 3 is written as minus cos pi by 3 is written as cos of pi minus pi by 3. Pi minus pi by 3. So cos of pi minus pi by 3. You know that cos pi minus theta formula is minus cos theta. Cos pi minus theta is equal to minus cos theta. So minus cos pi by 3 is written in the form cos of pi minus pi by 3 form. So cos of pi minus pi by 3 is equal to minus cos pi by 3. So cos y is equal to cos of pi minus pi by 3. Simplify this term. So cos 3 pi minus pi is 2 pi by 3. Pi minus pi by 3 is equal to 2 pi by 3. 2 pi by 3 means 2 into 60 degree, that is 120 degree. So here principal value of cos inverse x is close interval 0 comma pi. Close interval of 0 comma pi. This answer 2 pi by 3 is also belongs to this interval 0 comma pi. Therefore y is equal to 2 pi by 3. Y equal to 2 pi by 3 is also belongs to close interval 0 comma pi. Close interval 0 comma pi. Therefore y is here, let us consider y equal to cos inverse of minus 1. Therefore cos inverse of minus 1 by 2 value is 2 pi by 3. 2 pi by 3. And last one, third one, sine inverse of minus 1 by 2. Similarly, same as let's z equal to sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2. So we know that the principal value of sine inverse x is, the interval is minus pi by 2 comma plus pi by 2. Principal value of sine inverse x is equal to O's interval of minus pi by 2 comma plus pi by 2. Right. Next. So z equal to sine inverse of minus 1 by 2. So sine z is equal to minus 1 by 2. Sine z equal to minus 1 by 2. You know that the 1 by 2 value is equal to sine pi by 6. Sine pi by 6. So sine z is equal to minus 1 by 2 is equal to minus sine pi by 6. So sine pi by 6 value 1 by 2. So minus 1 by 2 is equal to minus sine pi by 6. So sine z is equal to minus sine pi by 6. Minus sine pi by 6 is written in the form sine of minus theta formula. So sine of minus pi by 6. You know that formula, sine of minus x is equal to minus sine x. So here minus sine pi by 6 is changed in the form sine of minus pi by 6. So sine z equal to sine of minus pi by 6. Therefore z equal to minus pi by 6. So this value minus pi by 6 is also belongs to the principal value of sine inverse x, close interval minus pi by 2 comma plus pi by 2. Right. So minus pi by 6 is belongs to close interval of minus pi by 2 comma plus pi by 2. Okay. Right. So z is, let us consider z is sine inverse of minus 1. Therefore the sine inverse of minus 1 by 2 value is minus pi by 6. So this three values, tan inverse of 1 equal pi by 4 and cos inverse of minus 1 by 2 equal 2 pi by 3 and sine inverse of minus 1 by 2 equal minus pi by 6. Substitute in given question. Therefore the required answer is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2 is equal to tan inverse of 1 answer pi by 4 plus cos inverse of minus 1 by 2 is 2 pi by 3 plus sine inverse of minus 1 by 2 is minus pi by 6. So simplify these terms. 4, 3, 6. Take LCM. Take it to LCM. So 3 4s are 12. So 3 pi. 4 3s are 12 plus 4 to 8 pi minus 2 times 6 is 12. So 2 pi minus 2 pi is equal to 3 pi plus 8 pi minus 2 pi is 9 pi by 12. 9 pi by 12. Okay. Right. So 9 pi by 12. So 3 is 9, 4, so 3 pi by 4 is equal to 3 pi by 4. Therefore, the required value of this constant tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2 is equal to plus 3 pi by 4. This is a required answer. Okay, very simple question. Very important formula. Listen, principal value of tan inverse x is open interval minus pi by 2 comma plus pi by 2, and principal value of cos inverse x is 0 comma pi close interval. Principal value of sin inverse x is close interval minus pi by 2 comma plus pi by 2. So the value of this tan inverse of one value is belongs to this interval open of minus pi by 2 comma plus pi by 2. Therefore this value pi by 4 is belongs to this interval. And also similarly same cos inverse of minus 1 by 2 value is belongs to this interval close interval 0 comma pi. So 2 pi by 3 is also belongs to close interval of 0 comma pi. And same last one, sin inverse of minus 1 by 2 value is minus pi by 6. That value minus pi by 6 belongs to the principal value of sin inverse x value close interval of minus pi by 2 comma plus pi by 2. Okay, right, very simple question. Right, next question. Next 12th question, question number 12. So sin inverse of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Find the value of this question. Okay, right, let's x equal to cos inverse of 1 by 2, then cos x is equal to plus 1 by 2. So 1 by 2 value is equal to cos pi by 3. Cos pi by 3 value is 1 by 2. So x is equal to pi by 3. This also belongs to close interval 0 comma pi. So close interval 0 comma pi is principal value of cos inverse x. Okay, right. So cos inverse of 1 by 2 value is pi by 3, and sin inverse of 1 by 2, let's y is equal to sin inverse of 1 by 2. Y is equal to sin inverse of 1 by 2. So sin y is equal to 1 by 2. So you know that the 1 by 2 is equal to sin pi by 6 value. Sin pi by 6 is 1 by 2. So sin y equals sin pi by 6, then the y value is pi by 6. So pi by 6 is also belongs to close interval of minus pi by 2 comma plus pi by 2. Listen, here close interval of minus pi by 2 comma plus pi by 2. Close interval of minus pi by 2 comma plus pi by 2 is principal value of sin inverse x. So the pi by 6 value, pi by 6 means that is 30 degree, is belongs to this interval close interval of minus pi by 2 comma plus pi by 2. Therefore the sin inverse of 1 by 2 is equal to pi by 6. Pi by 6. So required answer is cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2 is equal to, here cos inverse of 1 by 2 value is pi by 3 plus 2 into sin inverse of 1 by 2 value is pi by 6. So 2 6 pi by 3. So pi by 3 plus pi by 3 is 2 pi by 3. Pi by 3 plus pi by 3 is equal to 2 pi by 3. So required value of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2 is equal to 2 pi by 3. 2 pi by 3. Okay. Right, 12th question answer 2 pi by 3. Right. Next, question number 13. Listen, question number 13. If sin inverse x equal to y, then a is 0 less than or equal y is less than or equal to pi, and b is minus pi by 2 less than or equal y is less than or equal to pi by 2, and c is 0 less than y is less than pi, and d is minus pi by 2 is less than y is less than pi by 2. Choose the best answer in following a, b, c, d if sin inverse x equal to y. Listen, if sin inverse x is equal to y, sin inverse x is equal to y, then sin y is equal to x. Sin y equal to x. You know that the principal value of sin inverse x, you know that principal value of sine inverse x is close interval minus pi by 2 comma plus pi by 2. This is the principal value of sine inverse x. That means y, the y value is minus close interval minus pi by 2 comma plus pi by 2. Y is belongs to close interval minus pi by 2 comma plus pi by 2, or minus pi by 2 is less than or equal to y is less than or equal to plus pi by 2. Okay, so which one of the correct answer? So option B, minus pi by 2 is less than or equal to y is less than or equal to plus pi by 2. So answer is option B. This is the correct one answer. Okay, question number 13. Next question number 14. Question number 14. Next question number 14. Listen. The question number 14 is tan inverse of root 3 minus sec inverse of minus 2 is equal to A is pi and B is minus pi by 3, C is pi by 3 and D is 2 pi by 3. Which one of the following is correct answer? Right. Listen. Tan inverse of root 3 minus secant inverse of minus 2. Secant inverse of minus 2. Find the value of this question. So let us consider tan inverse of root 3 is x. Let's x equal to tan inverse of root 3. So tan x is equal to root 3. So root 3 is equal to, you know that root 3 is equal to tan pi by 3. So tan pi by 3 value is root 3. So tan x equal to root 3 is also equal to tan pi by 3. Which implies tan x is equal to tan pi by 3. So x value is pi by 3. This value is belongs to open interval of minus pi by 2 comma plus pi by 2. Here my open interval of minus pi by 2 comma plus pi by 2 is principal value of tan inverse x. Okay, right. So tan inverse of root 3 value is pi by 3. Pi by 3. And second one, secant inverse of minus 2. Let us consider y equal to secant inverse of minus 2. Y equal to secant inverse of minus 2. Right. So secant y is equal to minus 2. Secant y is equal to minus 2. You know that 2 is equal to secant pi by 6. So secant pi by 6 value is 2. Sorry, secant pi by 3. Cos pi by 3 value is 1 by 2 and secant pi by 3 value is 2. So here minus 2, so minus secant pi by 3. Secant pi by 3 value is 2. So minus 2 is also equal to minus secant pi by 3. Right. So secant y is equal to minus secant pi by 3 is written in the form secant theta is equal to secant of pi minus theta. So secant of pi minus theta is equal to minus secant theta. Here minus secant pi by 3 is written in the form secant of pi minus pi by 3. Minus secant pi by 3 is equal to secant of pi minus pi by 3. Okay, right. Here y is equal to pi minus pi by 3. So secant y is equal to secant of pi minus pi by 3 is 2 pi by 3. 2 pi by 3. Therefore y is equal to 2 pi by 3. Y equal to 2 pi by 3 is also equal to, is belongs to close interval 0 comma pi except 0. This value is principal value of secant inverse x. So the answer 2 pi by 3 is also belongs to principal value of secant inverse x. Therefore secant inverse of minus 2 is equal to 2 pi by 3. 2 pi by 3. So the required answer is tan inverse of root 3 minus secant inverse of minus 2 is equal to tan inverse root 3 answer is pi by 3 minus secant inverse of minus 2 value is 2 pi by 3. 2 pi by 3. Listen, denominator same. So 3. Pi minus 2 pi is equal to minus pi. So pi by 3 minus 2 pi by 3 is equal to minus pi by 3. Right. So the correct answer is option B. So option B is equal to minus pi by 3. This is correct one. Right. Listen. Exercise 2.1 is completed. Example 1, example 2 is homework. Very simple question. Next, properties of inverse Degramatic function. Properties of inverse Degramatic function. So this is properties of inverse Degramatic function, and its proof is deleted portion. Okay, only proof, only deleted portion. So these formulas are very, very important. So prepared very well these formulas. Listen. Properties of inverse Degramatic function. First of one, sine of sine inverse x. Sine of sine inverse x is equal to x when x is belongs to this interval, closed interval of minus 1 comma plus 1. Listen. So you know the sine value. So sine value here, x domain value, sine domain of the sine x value is x is belongs to R, and range of the sine x function is closed interval of minus 1 comma plus 1. Here sine of sine x, so we need sine of value, so sine value, sine function, this is a sine function. So here x is belongs to minus 1 comma plus 1. Here the range value, sine x value, range is minus 1 comma plus 1. Listen carefully. Sine of sinus x is nothing but sine x value. So this sine theta value, you know the sine theta value, the range of sine theta is closed interval of minus 1 comma plus 1. So sine of sine inverse x is equal to x when x is belongs to closed interval of minus 1 comma plus 1 only. Okay, right. Next, second one, sine inverse of sine x. Sine inverse of sine x. So sine inverse of sine x is equal to x. Sine inverse of sine x is equal to x. X is belongs to closed interval minus pi by 2 comma plus pi by 2. But here minus 1 comma plus 1. Here range value is x is belongs to minus pi by 2 comma plus pi by 2. Why sir? Listen carefully. First one formula is sine theta function. Sine of this value is theta, consider as theta. So sine theta function. So range of sine theta function is minus 1 comma plus 1. But second one, sine inverse of y form it. So let us consider y equal to sine x. So sine inverse y. So you know the sine inverse y, sine inverse, the range of sine inverse x form it is equal to closed interval of minus pi by 2 comma plus pi by 2. So this function is sine inverse x function, sine inverse theta form. So the range of the sine inverse theta function is closed interval of minus pi by 2 comma plus pi by 2. So therefore sine inverse of sine x equal to x. X is belongs to minus pi by 2 comma plus pi by 2. Okay, right. So this value is belongs to this interval only. So closed interval minus pi by 2 comma plus pi by 2 only. Okay, right. Next, third one formula, sine inverse of 1 by x. Sine inverse of 1 by x. So you know the reciprocal of sine x formula value is cosecant x, and also same similar is sine inverse of 1 by x is cosecant inverse x. Sine inverse of 1 by x is cosecant inverse x. You know the range of the cosecant x function is modulus x is equal to 1. That is x is greater than or equal to 1 or x is less than or equal to 1. This value that is mean x is belongs to set of all real number except open interval of minus 1 comma plus 1. This means set of all real number except open interval minus 1 comma plus 1. Same. So x is greater than or equal to 1 or x is less than or equal to minus 1 mean set of all real numbers except open interval minus 1 comma plus 1. Okay, right. Next, cos inverse of 1 by x is sec inverse x. Same as ranges, same type. X is greater than or equal to 1 or x is less than or equal to minus 1 or modulus x is less than or equal to 1 or set of all real numbers minus open interval minus 1 comma plus 1. Okay, right. Next, tan inverse of 1 by x. Tan its reciprocal cot x. So tan inverse of 1 by x is cot inverse x when x is greater than 0. When x is greater than 0, only positive value. So to allow only x is greater than 0. Okay, right. Here sine inverse of minus x. Sine inverse of minus x is equal to minus sine inverse x where x is belongs to minus 1 comma plus 1, and tan inverse of minus x is equal to minus tan inverse x is belongs to real number less than tan x function range is x is belongs to r, and sin inverse of minus x function here x is belongs to close interval of minus 1 comma plus 1, and cosecant inverse of minus x is equal to minus cosecant inverse x for every modulus of x is greater than or equal to 1. You know the formula, compare this formula, sin of minus x equal minus sin x, cos of minus x equal minus cos x, tan of minus cos x, tan of minus x equal minus tan x. Also same as here, sin inverse of minus x is equal to minus sin inverse x, but they will restrict the domain x is belongs to close interval of minus 1 comma plus 1. Okay, so compare sin of minus x, cos of minus x, and tan of minus x formula. Same time here, sin inverse of minus x equal to minus sin inverse x, and tan inverse of minus x equal to minus tan inverse x, cosecant inverse of minus x is equal to minus cosecant inverse x. Okay, right. Listen here, cos inverse of minus x, cos inverse of minus x, you know that, so cos of minus x and secant of minus x is positive, cos of minus x is cos x, and secant of minus x is plus secant x, right. Listen here, cos inverse of minus x is equal to pi minus cos inverse x, pi minus cos inverse x. Listen, pi minus theta, cos of pi minus theta is minus cos theta, cos of pi minus theta is minus cos theta. So here pi minus cos inverse x, use this format, pi minus theta format. So cos inverse of minus x is equal to pi minus cos inverse x, pi minus cos inverse x. So here x is belongs to minus 1 comma plus 1. Similarly, same as secant inverse of minus x equal to pi minus secant inverse x, modulus x is greater than or equal to 1, and only one different, cot inverse of minus x is equal to pi minus cot inverse x, for all x is belongs to r. So these three formula compared to three formulas only, but domains are different. Here x value is different. Okay, here these three formulas are same. Sin inverse of minus x, minus sin inverse x, minus of this function, minus of this function, but here pi minus of this function. Okay, right. Listen, 12th one, sin inverse x plus cos inverse x equal to pi by 2. Sin inverse x plus cos inverse equal to pi by 2. Tan inverse x plus cot inverse equal to pi by 2. Here x is belongs to minus 1 comma plus 1, and tan inverse x plus cot inverse x equal to pi by 2. Here x is belongs to set of all real numbers. Okay, so cosecant inverse x plus secant inverse x is equal to pi by 2. Here modulus x greater than or equal to 1, that is x is greater than or equal to 1 and x is less than or equal to minus 1. So that is x is belongs to set of all real number except to open interval minus 1 to minus plus 1. This is same. Okay, right. Next, tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus x5 formula. Listen, tan inverse of x plus tan inverse y is equal to tan inverse of x plus y, numerator left hand side plus, here numerator x plus y, use plus, and denominator is opposite function, opposite sign, here plus 1 minus xy. Listen, formula number 16, tan inverse of minus, here numerator x minus y, denominator 1 plus xy. So numerator is minus, then denominator is plus. So left hand value, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus xy. Listen, here the xy value is less than 1 and the xy value is greater than minus 1. Only this possible, xy is less than 1 in the formula number 15 and xy is greater than minus 1 in problem number 16. Okay, right. So 2 tan inverse x equal to sin inverse of 2x by 1 plus x squared, modulus x is less than or equal to 1, this formula. So 2 tan inverse x equal cos inverse of 1 minus x squared by 1 plus x squared, so x is greater than or equal to 0, and 2 tan inverse x equal to tan inverse of 2x by 1 minus x squared. Minus 1 less than x is less than 1. So this formula is nothing but tan inverse x plus tan inverse formula, tan inverse x plus tan inverse formula. So here y is replaced x, so tan inverse x plus tan inverse x equal to tan inverse of x plus x, that is 2x, 1 minus x into x is x squared. So last question 19, question formula number 19, nothing but y is replaced in plus x in formula number 15. Same result, 2 tan inverse equal to tan inverse of 2x divided by 1 minus x square for every open interval minus 1 comma plus 1. X is belongs to open interval minus 1 comma plus 1 only. Okay, so this 19 formula is very very important. Okay, right. So listen, important Degramatic identities formula. You know these formulas study in the last class, grade 11 and grade 10. Okay, so sin square theta plus cos square theta is equal to 1, which implies 1 minus cos square theta. 1 minus cos square theta is equal to sin square theta, and 1 minus sin square theta is equal to cos square theta. So same result, sin square theta plus cos square theta is equal to 1. So which implies 1 minus sin square theta equal to cos square theta, and 1 minus cos square theta equal to sin square theta. Okay, right. Next, secant square theta minus tan square theta equal to 1. Similarly, which implies secant square theta equal to 1 plus tan square theta, or tan square theta is equal to secant square theta minus 1. So same result. Okay, right. Next, third one, cosecant square theta minus cos square theta equal to 1. Here sin square theta plus cos square theta 1, secant square theta minus tan square theta 1, cosecant square theta minus cos square theta 1. Okay, so which implies cosecant square theta equal to 1 plus cos square theta, or cos square theta equal to cosecant square theta minus 1. Okay, right. Next, fourth one, sin 2 theta. Sin 2 theta is equal to sin theta cos theta, and half angle formula sin theta equal to 2 sin theta by 2 into cos theta by 2. Here 2 theta, but here sin 1 theta. So 2 theta divided by 2. So sin theta is equal to 2 sin theta by 2 cos theta by 2. Next, cos 2 theta. Cos 2 theta equal cos square theta minus sin square theta, or 1 minus 2 sin square theta, or 2 cos square theta minus 1. So 3 result is same as cos 2 theta. So cos 2 theta equal cos square theta minus sin square theta equal to or 1 minus 2 sin square theta, or 2 cos square theta minus 1. Okay, right. Which implies the half angle formula 2 theta, here cos 2 theta divided by 2 is cos theta. 2 theta by 2 is theta. So also cos theta is equal to same cos square theta by 2 minus sin square theta by 2, which is similarly same as here cos theta equal 1 minus 2 sin square theta by 2, and cos theta equal 2 cos square theta by 2 minus 1. Okay, right. Next, very very important 3 formulas: cos 3 theta, sin 3 theta, and tan 3 theta. Cos 3 theta is equal to 4 cos cube theta minus 3 cos theta, minus 3 cos theta, and sin 3 theta equal 3 sin theta minus 4 sin cube theta. Tan 3 theta equal 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Okay, so this formula is very very important. Already the formula ellame grade 11 Degramatic functions topic la full ah explain panni proof oda paathirupinga neenga. Okay va, adha once recall pannunga. The formulas ella use agum. Inverse Degramatic functions sum solve பண்ணும்போது the formulas எல்லாமே நமக்கு யூஸ் ஆகும். கால்குலஸ்லையும் யூஸ் ஆகும். டிஃபரன்ஷியல் கால்குலஸ், இன்டெக்ரல் கால்குலஸ் உங்களுக்கு யூஸ் ஆகும். ஓகே, ஸோ இதனால் தெளிவாக படிச்சுக்கலாம். ஃபார்முலாஸ் ரொம்ப முக்கியம். ஃபார்முலாஸ் தெளிவாக படிச்சுட்டீங்க அப்படின்னா கிளியராக நம்ம சால்வ் பண்ணலாம், சம் சால்வ் பண்ணலாம். ஓகே, ரைட். நெக்ஸ்ட்டு exercise number 2.2. listen, question number 1, prove that exercise 2.2, prove that three sin inverse x equal to sin inverse of 3x minus 4x cube, 3f minus 4x cube. So x is belongs to closed interval minus 1 by 2 comma plus 1 by 2. X is belongs to closed interval minus 1 by 2 comma plus 1 by 2. Right. Prove this question. Listen. 3 sin inverse x equals sin inverse of 3x minus 4x cube. 4x cube. take RHS. RHS is equal to sine inverse of 3x minus 4x cube. 3x minus 4x cube. Let's x is equal to, put x equal to, here this x equal to sine theta. Let us consider x equal to sine theta, which implies RHS is equal to sine inverse of 3x is replaced sine theta, so sine theta minus 4 sine x cube, sine cube theta. Listen, sine inverse of this format, we know that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So this form 3 sine theta minus 4 sine cube theta is written as sine 3 theta. Sine 3 theta. Okay, right. Listen, we know that sine inverse of sine x. You know that sine inverse of sine x is equal to x. Sine inverse of sine x is equal to x for our x is belongs to close interval minus pi by 2 comma plus pi by 2. Okay, listen, here sine inverse of sine 3 theta is equal to 3 theta. Here x equal to sine theta, which implies theta equal to is written as sine inverse x. So theta is equal to sine inverse x. This value sine inverse x is replaced theta. So 3 theta is equal to 3 sine inverse x. 3 sine inverse x. Okay, so here RHS value is 3 sine inverse x. So is equal to RHS. So only use this formula, sine inverse of sine x is equal to x. And another Degramatic identity is sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Okay, very simple question. Two formula is very important. Right. Next question number 2. Next second question. Listen. 3 cos inverse x is equal to 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. X is belongs to close interval of 1 by 2 comma 1. X is belongs to close interval of 1 by 2 comma 1. Prove that. Listen, take the RHS value. RHS is equal to cos inverse of 4x cube minus 3x. 4x cube minus 3x. You know that the formula cos inverse of cos x equal to x. So this format 4x cube minus 3x is converted in cos x format. So put x equal to cos theta. Similarly, same method and first question x put x equal to sin theta. So sin 3 theta formula. Here put x equal to cos theta. So RHS is equal to cos inverse of 4 cos cube theta. X is cos, so x cube means cos cube theta minus 3 cos theta. Minus 3 cos theta. Right. So cos 4 cos cube theta minus 3 cos theta. We know that the formula is cos 3 theta is equal to 4 cos cube theta minus 3 sin theta. Minus 3 sin theta. So 4 cos cube theta minus 3 sin theta is equal to cos 3 theta. So cos inverse of cos 3 theta. Cos inverse of cos theta. And once more formula, you know this. And cos inverse of cos x formula. Cos inverse of cos x is equal to x. Cos inverse of cos x equal to x. So x is belongs to closer to 0 comma pi. So use this formula cos inverse of cos 3 theta. So cos inverse of cos 3 theta is 3 theta. 3 theta. Right, so cos inverse of cos 3 theta equal 3 theta. Here theta is x equal cos theta, which implies theta is equal to cos inverse of x. Cos inverse of x. So 3 into theta is cos inverse x. So cos inverse 3 cos inverse x is left hand side. So therefore right hand side is equal to left hand side is also equal. Hence prove this question. So very important, these two formulas only this question. Cos 3 theta equal to 4 cos cube theta minus 3 sin theta. Next cos inverse of cos x is equal to x. Okay, bye. Next question number 3 and 4. Question number 3 and 4 use this formula tan inverse x plus tan inverse y format, but question number 3 and 4 is deleted portion. So 3, 4 deleted. Next example 3, listen, example 3 is same type, sin inverse of 2x root of 1 minus x square equal to 2 sin inverse x. Let x equal to sin theta. Let us take right hand side, sin inverse of 2x root of 1 minus x square, put the value x equal to sin theta. So 2 sin theta into root of 1 minus x square. You know the formula root of 1 minus x. 1 minus sin square theta is equal to cos square theta. So root of cos square theta is cos theta. So 2 sin theta cos theta equals sin 2 theta. Use this formula, sin inverse of sin 2 theta is equal to 2 theta. Here theta is sin inverse x is equal to 2 sin inverse. Very simple question. So example 3, first and second subdivision, very simple question. So this is homework. Next example number 4 is deleted portion. Example 4, deleted portion. So remaining question is in next class. Okay, bye.